Okay, welcome back to the fourth lesson of this unit, and we are going to be graphing linear functions today. Okay, so recall a function has one output for every single input, right? So for 1x, it only produces one y value, okay? So we can graph this, okay? We've done this before in the past, right? Math 8 and 9, but we are going to, just review a little bit more graphing lines, okay? So here is the first example. It says use the table values to graph the function y equals 2x plus 1. Okay, so we can use the table value. Now I have listed some x values that we can use. Obviously, you don't have to use these x values, but I just listed out some. Okay, now how this works, recall is then we have y equals 2 times the x value. Now we said the x would be -4, so we're going to put -4 into x plus 1. Okay, so 2 times -4 is -8 plus 1, that gives us -7. Okay, so this will be -7 here. And I'll show you one more. So then we're going to put -2 in this case for x. So y equals 2 times -2 plus 1. That would be -4 plus 1, and that is -3. So then we put the y value as -3 right there. Okay, so remember this is the input for the x, and this is the output. And you can see why they're called input and output, right? You see we are putting x into the function, and the result is the output, and that is the y value of -3. Actually, I have some space, so I might as well do one more. When x is 0, you put 0 into x, plus 1, 2 times 0 is 0, plus 1 equals to 1. So when x equals to 0, y is 1. Okay, you can do the same thing for the next two numbers, and you should get 5 and 9. Okay, so that will complete this table of values. Then we can plot the points. Okay, so again, the first point would be -4, -7. So again, x being -4 is right here. You move 4 from the origin to the left. And y value is -7, so you move 7 units down. And you just keep plotting the rest of the points. You have -2 and -3. That will be right here. 0, 1 is this point right here. 2 and 5. And 4 and 9. Okay, so you can see it looks like a straight line. So now you just need to take our ruler. Now it's going to be a little bit more challenging for me to draw this on the screen. So, but I'll try my best. Okay. Something like that. Oh, that's not bad. Okay, so you can then draw the arrows. Make sure you include the arrows at the end because it shows that it keeps going to the right and keeps going to the left, also up and down. Okay, so that's the graph. Now, what is the domain and range? Recall, domain is the list of possible x values. This is a graph that continues to moving on to the right and left. So it's going to be an interval. I'm going to write this in an interval notation. This would go from, again, domain is the possible x values. So from left to right. Because of the arrows, it continues to go to the left. So goes to infinity, sorry, -infinity, and it keeps going to the right. And that would be the positive infinity. And recall, we do not include infinities. Whereas range, similarly, right, for the range, that's the possible y value. So we're looking from the bottom to the top. And again, because of the arrows, it goes from the -infinity to positive infinity. Okay, and that would be your range. Okay, so that's how you graph using a table of values. Okay, so here's a practice question for you to try. Again, I have listed, in this case, 4 x values for this function right here. So I'll let you do it, and I will show the answer in a bit. Okay, so you should plug in -8 into x plus 2. That will be -2 plus 2, so that gives you 0 for the y value. And you can do the same thing for -4. You put that into x. Okay, so again, anytime you see x, you're going to put these x values instead. And the rest you just copy down. Okay, 1/4 times -4 is -1, plus 2 is 1. You can do the same thing for 0. So 1/2, oh sorry, 1/4, not 1/2. 1/4 times 0 plus 2 is 0 plus 2, which is 2. And if you do the last one, you should get positive 3. Okay, so now we can plot the points. -8 and 0 is right here. -4 and 1 is right here. 0, 2, 4 and 3. Okay, now you can join the points. it should look something like this. Okay, I just missed it. Okay, hopefully you can do a better job than me. Okay, there we go. Now this time I'm going to write the domain range in the set notation. Okay, so domain will be a set of x values such that x is simply the element of all real numbers. Okay, so recall this is the interval notation. Okay, that's how you write the domain range in interval notation. This would be the set notation. Okay, you should know both. Okay, you need to know how to do both. The range in this case, again, now the reason why it's all real numbers, again, because it's going to the right and keeps going to the left. Similarly for range, it keeps going downwards and keeps going upwards. So the range would just be the set of y values such that y is the element of all real numbers. Okay, so hopefully you're not finding graphing linear functions too difficult. Using a table value is only one of the methods. Okay, I'm going to show you another method. Okay, this time we're going to graph the linear function using the x and y intercepts. Okay, so recall x-intercept is basically the point. Okay, so is the point that crosses x-axis. Okay, and this happens when y equals 0. Okay, so that's the key. Okay, so again, the point that crosses this x-axis is the x-intercept. Okay, now it happens when y equal to 0. So notice all the y values on this line would be 0. Okay, so that's the key to find the x-intercept actually. Okay, it's because we already know y would equal to 0. So what we can do is we have this equation. Now instead of writing y, we can change y to 0. Okay, because we know it happens when y equal to 0. So now I can solve for x. You can see we only have one single variable left, so we can solve for x. Okay, now 4 times 0 is 0, so well, minus 0. I mean, when you minus 0, it doesn't do anything, so I'm just going to rewrite this as 3x equals to 12. Now you can solve for x by dividing both sides by 3, so you get x equals to 4, and that would be your x-intercept. Okay, so your x-intercept is right here. It happens at 4. Okay, so again, it's going to be on the x-axis, right? That's why it's called x-intercept. Now you might have guessed it, right? To find y-intercept, then this would be the point that crosses y-axis. And this happens or occurs, same thing, when, well, if x-intercept happens when y equal to 0, then y-intercept happens when x equal to 0. Okay, so similarly, I'm going to solve for, in this case, y by simply putting 0 into x. I'm going to put 0 into x. Then I can solve for y. Well, 3 times 0 is just 0, so I'm not going to even write that. I'm just going to write negative 4y equals 12. Now to solve for y, I simply divide both sides by negative 4. So 12 divided by negative 4 is negative 3. So there is your y-intercept. So then I can plot that point. Negative 3 is right here. Okay, so again, y-intercept occurs on the y-axis. So now I have 2 points. And I mean, to be honest, to draw a line, all you need is 2 points, right? Because then you can just connect those 2 points. Then you can make a straight line. Right? So that's what you need to make a straight line, right? 2 points. Okay, so if you draw it, it looks something like that. Okay, so there is your graph. Okay, so I'll let you try the next one here. We have 3x plus 7, y equals 21. So again, all you have to do is to find your x-intercept and your y-intercept. Then you have 2 points. Then you can graph it. Okay, so give that a try. Okay, so to find x-intercept, again, you let y equals 0, right? That's how you find x-intercept. So then I have 3x plus 7 times 0 equals 21, which means 3x equals 21, and therefore x equals to 7. So there is my x-intercept. And then to find y-intercept, you let x equals 0. So then you go 3 times 0 plus 7y equals 21. 3 times 0 is 0, and we then end up with 7y equals 21. Divide both sides by 7, you get y equals 3. And there is my y-intercept. And again, that's all we need to graph a line. So if I just join these 2 points, then I can have my graph. There you go. Draw the arrows at either end. Okay, so today I show you 2 different methods of graphing a line. Right? One is using the table of values, and the other one is finding their intercepts. We will learn different methods later on, next chapter. But for now, I think these are 2 very good methods to graph lines. Okay. Now, obviously, math is not all that useful without word problems, right? So we are going to be looking at some word problems next. Before we do, we're going to be looking at some vocabularies. Okay. So key terms: independent variable. Okay. So what's an independent variable? Well, it says independent variable is a variable whose value is not determined by the value of another variable, and whose value determines the value of another. Well, the other is called the dependent variable. Okay, so for example, okay, if you work, right, if you have a part-time job, then an independent variable could be like the number of hours worked. And the reason why this is independent is because this actually determines, right, again, whose value determines the value of another. This determines how much money you actually earn. Okay, if the more hours you work, the more money you get, right? The less hours you work, then the less money you get. So the number of hours worked would be an independent variable because it's not affected by other things. Okay, so that's an example. Basically, essentially, time. Okay, if you have time is essentially always independent variable because time does not depend on anything. Okay, your age, right? That does not depend on anything. Okay. Dependent variable says here it's a variable whose value is determined by the value of another, determined by the independent variable. So for example, that this would be the amount of money earned. Okay, that would be the dependent variable because again, it depends on how many hours you work. Okay, so that's an example of that. So hopefully that makes sense to you. Independent variable is something that is not determined by other variables. Instead, it actually determines the value of another variable. Okay. All right. Discrete data and continuous data. Okay, so what's the difference here? It says discrete data is data that can only take in certain values. Okay. For example, your shoe size. Because the shoe size would be like 5, 5.5, 6, 6.5, 7, and so on. There is no such thing as shoe size 3.7201779. Okay, there's no such thing, right? So there is like a restriction on the values that you can take. For example, number of people, right? It only takes whole numbers, right? There is no 1.35 people. It's either 1 person, 2 people, 3 people, 5 people, 10 people, 1,000,000 people, and so on. There is no fraction of a person, right? So it only takes certain values. Okay, number of chairs, right? Again, in this case it does not take fractions. There's no 3.5 chairs. Okay, so these are what we call discrete data. Whereas continuous data is the data that can take any value. So for example, time, right? There's no you can split time into smaller pieces, and that's fine. You can have 1.350012 seconds. I mean, it's possible, but I mean, we don't really count that smaller, that fine value, but it is definitely possible. Height, right? That's possible. You could have 1.3761 meters as your height, right? You can make it even smaller, right? However small you want. So these would be continuous data, okay, etc. Okay, now let's look at this example here with some more problems. It says the cost C in dollars of renting a hall for a dance is given by the formula C equals 4n plus 100. Whereas n is the number of people in attendance, the hall can hold a maximum of 500 people. We're looking for the dependent variable and the independent variable. Okay, so for in this case, independent variable and dependent variable. Well, what is it, right? The independent variable, well, I'll spell the whole thing. Independent variable. Well, the independent variable would be the number of people in attendance. Number of people in attendance, because this will determine the cost. So that would be the cost of renting a hall. Okay, so again, the number of people in attendance actually that determines how much it costs. Okay, so the more people that attend, then the more expensive it gets. Okay, so part B says graph the function up to 500 people attending. So independent variable is, recall, always the x value, and dependent variable is always the y value. So here we have the number of people, and here we have, here's x, or actually it's not x, in this case it's n. We have the cost axis here, and this would be the cost. Okay, now I am going to just use 100, 200, 300, 400, and 500 as my x values, or n values. Okay, now I don't actually quite know what my cost is going to be, so for now I'm not going to actually graph quite yet. Okay, what I'm going to do is I'm going to make a table, right? I have my n and I have my c, which is equal to 4n plus 100. So I'm going to put 0 as my n. I'm going to put 100, 200, all the way to 500. Okay, there is my table of values. So to finish the table, then I simply put 0 in the first case into n, and this will give me 100. That's my cost for renting the hall if nobody comes. That would be a little sad, but that's the case. Okay, if there's 100 people comes to the, what was this meeting here? To the dance. So that will be 4 times 100 plus 100. This will be 400 plus 100, which is 500. Okay, so the cost will be $500 if 100 people attended the dance. Okay, I'll do one more, and then I'll just fill the rest in. Okay, so 4 times 200 plus 100, that's 800 plus 100, which is $900. Okay, you can do the same thing for the next three n values, and you will get $1,300, $1,700, and $2,100. Okay, so now I know my y value, so then I can figure out how I want to scale my axis. Well, the maximum here is 2,100, so I guess I'm gonna go up by 200 each time. Okay, that means I need at least 12 lines. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's pretty even. Each line is going to represent 200. Okay, so that's 200, 400, 600, 800, 1000, 1200, 1400, 1600, 1800, 2000, 2200. Wait, did I skip a number or something? Oh, okay, something good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I guess all I need is 11 9. So of course. What am I talking about here? Okay, so we can plot the points. Okay, let me do that in blue. When n equal to 0, that'll be right here. The y value is, or the cost is $100, so roughly there, right? When n is 100, the cost is 500. That'll be exactly halfway between 400 and 600, somewhere there. 200 and 900, that'll be right here. 300 and 1300 will be here. Roughly speaking, okay, I'm doing my best to estimate it. 400 and 1700 will be right here. 500 and 2100 will be right here. Okay, so obviously it's off a little bit, but it should be a straight line. Let's see how good my estimate. Oh my gosh, my sketch is pretty bad. Okay. Actually, close enough. I guess it almost looked like a straight line. Now here, my question to you actually is, should we join the points to make it a straight line? Okay. Now the answer is no, we should not. The reason being, if you are connecting the dots, you're saying every single point on the line actually counts. But if we actually join the line, okay, so for example, if you draw it like that, that means this is one of the points. That will make sense. But that point could be 300.5. But n represents people. You cannot have 300.5 people in attendance. Okay, that does not make sense. So in this case, the number of people, as we mentioned earlier in this previous page, the number of people would be discrete. In that case, we do not join the points. Okay, we do not join the points. We only join the points if both x or both independent and dependent variables are continuous. Okay, let me say it again. You only join the points if both independent variable and dependent variable are continuous. Okay, so that's part B. For part C, if you want to find the cost, then you go C equals, okay, the formula is 4 times n plus 100, which means I can then plug 327 into n plus 100, and then just put this into a calculator. Okay, so 4 times 327, 4 times 327 plus 100 gives you $1,408. Okay, so that's part C. Finally, part D, it says if it costs $896 to rent a hall, how many people attend the dance? Okay, so this is the cost. So what we're gonna do now, instead of put $896 into n, we're gonna put $896 into the C variable, the cost, because that's what the cost is. And now we are solving for n, right? Because remember, n is the number of people in attendance. So this is a linear equation. To solve for n, you're going to minus 100 on both sides. Okay, let me actually show you the work in this case. Minus 100 here, minus 100 there. You get 796 equals 4n. Then you divide it by 4, divide it by 4. You get n equals 199. Okay, so people. And that would be the answer. Okay, finally, part E, it says what is the increase in cost per person? Well, you can see from the table actually, when you increase by 100 people, you increase the price by $400. Well, then how much is the increase per person? Well, you increase $400 when you increase 100 people. And therefore, the increase in cost per person would be $4 per person, right? Because that's the increase 100 people. So you can see 400 divided by 100 is $4 per person. Again, you can see this from 100 to 200, you increase 100 people. But from 500 to 900, again, you increase by $400. So every person, each additional person that attends, it's going to cost $4 extra. Okay? Hopefully that makes sense to you. And this is the idea of rate of change. We will talk more about this idea again next chapter, but this is like a little preview. Okay, it's a rate of change. Okay, so here is the last example I need to show you. It says the graph shows the fuel consumption of a truck with a full tank of gas at the beginning of the journey. Volume is the function of distance traveled. Okay, volume is a function of distance traveled. So you can see this is the volume of the gas, right, or volume of the tank, the fuel in the tank, and this is the distance traveled. We are looking for the rate of change, and we want to describe what it means. Okay, so we can do similar thing to what we just did earlier. We can actually make a table here, right? You can see when the distance is 0, we have volume. We have 80 liters of gas. We can use another point, so that's this point right here, right? That's the 0 distance. The distance is 0. The amount of gas will be 80 liters. We can also use the second point right here. when the distance traveled is 500, then we have, well, 0 liters of gas left, okay? So what is the rate of change? Well, rate of change is going to be how much gas we used per kilometer, okay? Well, we used 80 liters of gas. Now, because we're using it, we're not increasing the amount of gas. We're actually decreasing the amount of gas. So we are using negative, or we are using 80 liters of gas, which means the change in the volume is negative 80, correct? Because it's decreasing. Now, we drove for 500 kilometers. Okay, so, and therefore, the rate of change is going to be negative. If you put this into a calculator, 80 divided by 500, that gives you negative 0.16 liters per kilometer. Okay, so you just take the unit, and that will be your rate of change unit, right? So you can see that's you're using 80 liters of gas for 500 kilometers. If you simplify that or just put that into a calculator, you get negative 0.16 liters per kilometer, which means, okay, what does that mean? It means for every, well, actually, you know what, I'm going to write it this way. It consumes 0.16 liters of gas for every kilometer traveled. Okay, so that's what it means. Okay, it consumes 0.16 liters of gas for every kilometers traveled. Again, it's consumption because it's negative, right? It's decreasing. Okay, part B says write down the coordinates of the horizontal and vertical intercepts, so the x-intercept and y-intercept, and then describe what it means. Okay, so we have our let's just call this the what variables do we use? It doesn't say. Okay, so let's just call this the x-intercept. The x-intercept is this point right here, and that is 500, 0. Now, what does that mean? Okay, it actually means, well, if you traveled, wait, there's two L's here. Shoot. If you travel 500 kilometers, you would empty the tank. Empty the tank. Okay, that's what it means, right? If you travel 500 kilometers, well, then there's no more gas left. Okay, the y-intercept is 0, 80, right? That is this point right here. Okay, and what does that mean? Well, it means initially you have 80 liters of gas in the tank, right? Initially, because we haven't moved yet, right? The distance traveled is 0. That's why it's initially, because we haven't traveled anywhere, right? So initially, we have 80 liters of gas in the tank. Okay, so that's what that means. Finally, part C says, what's the domain and range? Well, domain, in this case, again, from left to right. So if you look at this graph, the leftmost point is here. The rightmost point is here. So what are the x values? This is a, actually, this is a good point. This would be a continuous data, again, because two things. Volume is always continuous, right? You can break that into a smaller, even smaller amount. And same as distance. And also you can see that the graph, you know, it's a straight line, right? And it's a line. It's not just a bunch of dots. It's actually a straight connected line. Okay, it's a line segment. So this could be written as an interval or a set notation. Okay, it doesn't matter. I'm gonna write this in a set notation actually. Okay, so it will be the domain. Domain will be the set of x values such that x goes from, again, the leftmost point has an x value of 0. You should use the less than equal sign because you can see it's a solid dot, less than equal to x, and x is smaller than equal to 500, right? That's the distance. Okay, whereas the range, we're looking from the lowest point to the highest point. The lowest point is right here. The highest point is right here. Okay, so the lowest y value, okay, remember range is the set of y values such that the lowest point is at 0. So y is bigger than equal to 0. But y is smaller than equal to the biggest y value, which in this case is 80 liters of gas. So there is your range. Okay, so hopefully that's the end of this lesson. Hopefully that makes sense to you. Now you have some practice questions to do, and let me know if you need some help. Okay, good luck.